Welcome to ETAP Ground Grid System module. This module is a perfect tool with impressive capabilities in order to design, analyze, and optimize your ground grids. Basically, the ground grid system is an essential part of a substation in order to make a safe environment available to both engineers and equipment. ETAP, as a verified and validated software, provides accurate and cost-effective solutions for your ground grid systems. For the ground grid studies, ETAP fully employs the empirical methods based on IEEE 80 and 665 standards to model a variety of regular shaped grids. In addition, ETAP uses the finite element technique and the state-of-the-art electromagnetic method for an accurate analysis of any irregular shaped grid model. For a convenient modeling, ETAP provides the flexible graphical user interface with three simultaneous views of your ground grid: the top view, the cross-section soil view, and the 3D grid view with animation options. Furthermore, the integration of the ground grid system into the ETAP one-line diagram allows for automatic update of the fault currents based on the short-circuit studies. ETAP ground grid system is fully integrated with ETAP one-line view, where you may define a grounded system and overlay it on any selected substation in the network. This unique feature enables engineers to visualize their ground grid systems on the one-line diagram and seamlessly utilize short-circuit results for ground grid studies. After the short-circuit calculation, simply right-click and choose to update the fault current through the one-line diagram. Now, you can double-click on the grid to open the design interface and see that the values have been directly populated and ready to use for ground grid analysis. There are quite a few other features provided by the ETAP ground grid module, including an extensive user-expandable library, a 3-layer surface material and soil configuration, and allowing for extended boundaries. This module considers workers' weight, ambient temperature, current division, and projection factors, and has the capability to import your designs from AutoCAD and export the results to a desired document format. Let's start by introducing ETAP ground grid system modeling capabilities. Actually, engineers can create a new design simply by dropping one of the IEEE standard layouts. For example, a rectangular model with a user's predefined configuration on the ground grid design editor. ETAP automatically updates the three views of your ground grid: the top view, the soil view, and the 3D view, which make an elegant environment to visualize and design any type of ground systems. Alternatively, an engineer may create a basic model and expand that design using rods and conductors to any complicated irregular configuration in the finite element method. Then, the layers of surface material and soil configuration may be easily modified through the cross-sectional soil view. For the convenience of the engineers, a variety of rods and conductor types are available in the ETAP library, which may be expanded by the users as well. ETAP allows the users to copy and utilize their previous designs as templates multiple times in the same or a different project, or import their design from AutoCAD software. In addition, it's possible in ETAP to combine and connect multiple ground grids through the conductors and analyze the whole integrated design. Now, to perform the study, a number of options and parameters such as workers' average weight, ambient temperature, boundary extension, fault current, and duration may be set, and the analysis is performed with a single click of a button. Following the calculations, ETAP reports step and touch voltages, resistance to ground, ground potential rise, and reflection and decrement factors. ETAP automatically checks and reports any violations according to the tolerable limits and uses 3D plots with contouring capability to visualize the grid voltage profiles. In addition, as a remarkable feature, ETAP is capable of optimizing the number of conductors and rods for a ground grid design with minimum cost. The optimization is done based on the IEEE method with a single click in ETAP. The output provides the optimum solution and you are able to have it automatically applied to your design. Following the studies, ETAP provides three output formats for the results: alert view, report documents, and 3D plots. The first type of output presents a summary of the results and probable alarms and warnings based on the tolerable limits. Second, you may generate different formats of report documents or export results in an Excel spreadsheet format. The third type of output is through the ETAP color-coded 3D plots with 2D contouring, where an engineer can visualize ground grid voltage profiles, evaluate the design, and even compare multiple design alternatives side by side. Let's see the advantage of ETAP ground grid module through an example. In this example, we've designed a 4x9 conductor rectangular shaped ground grid with 4 number of rods placed at the corners. The design includes the types and costs for individual conductors and rods. As a result of analyzing this specific case, the maximum touch voltage exceeds its tolerable limit. Using the plotting capability in ETAP, the peak touch voltages are clearly observed at the corners of the ground grid system voltage profile. Therefore, in order to bring the maximum touch voltage within its tolerable limit, it should be alleviated on these corners. As a solution with the finite element modeling, an engineer may now choose to use 4 sets of crossing conductors at the grid corners, which reduce the touch voltage by almost 13%, and simply resolve the issue. The touch voltage drop of the grid corners can be observed through the plot as well. Alternatively, the IEEE method could be used. However, according to the standard, the conductors and rods can only be added to the whole grid uniformly. In this case, an equivalent design with maximum voltage drop similar to FEM solution would require a total of 8 more conductors at both X and Y directions. A quick material cost comparison shows that the design with FEM results in 32% of savings, and yet it doesn't include the installation costs, considering which would make the ETAP provided FEM technique even more cost-effective and favorable for ground grid studies. As a conclusion, ETAP enables engineers to quickly and accurately model, analyze, visualize, and optimize their ground grids. ETAP is the most comprehensive and widely used enterprise solution for the design, simulation, operation, control optimization, and automation of power systems. Please contact us if you have any questions or need more information about the ETAP ground grid system module.